Hi, in this video we are going to discuss about different types of regression in the supervised learning. In that we will start with the linear regression. Linear regression is a predictive model used for finding the linear relationship between a dependent variable and one or more independent variables. We can see the graph. In the graph, x-axis is the independent variable and y-axis is the dependent variable, and in linear regression there is a linear relationship between independent variable and dependent variable, like the Ohm's law, variation of voltage with respect to current, right? It is linear. So linear regression is about the linear relationship between x and y. As we discussed here, y is our dependent variable which is continuous, numerical, and we are trying to understand how y changes with x. So if we are supposed to answer the above question, for example, what will be the GRE score of the student if his CGPA is 8.32? Our go-to option of course will be linear regression, because the CGPA, relationship between the CGPA and GRE score, right? It will be linear. So maybe the x-axis will be 8.32. You can find out in x-axis CGPA and y-axis GRE score. So at 8.32 we can see in y-axis what is the value, that is the GRE score. Other examples of independent and dependent variables. Suppose say x-axis is the rainfall and y is the crop yield, x is the advertising expense and y is the sales. So it means linear relationship. If rainfall increases, crop yield increases. If advertising expenses increases, say the sales is increasing. Linear relationship. X is the sales of goods and y is the GDP. These are some of the examples of linear regression. In linear regression, there are two types of regression. One is the simple linear regression and another one is the multiple linear regression. In simple linear regression, there is one x and one y, one independent variable and one dependent variable. If there are more number of, say, independent variables, then we call that as the multiple linear regression. But here there is only one x and y. X is related to y, that is simple linear regression. We can see in multiple linear regression there are so many x's, x1, x2, x3, x4, and they are all related to y. So this is multiple linear regression. Right, then what is the simple linear regression model? As the model is used to predict the dependent variable, because the model basically has to predict the dependent variable y for given x. The relationship between the variables can be written in this format. This equation is yi is equal to beta naught plus beta 1 x1 plus sigma I, where y, as we discussed, is the dependent variable y, beta naught is the intercept, beta 1 is the slope coefficient of that linear graph, xi is the independent variable, right, x-axis, and here the sigma I is the random error term. So this is a simple equation or a model, we can say, that can be used to obtain the relationship between y and x. Now we will see some of the important terminologies in regression analysis. One is the outliers, Suppose there is an observation in the data set that has very high or very low value compared to the observation in the data, that is, it does not belong to the population. Such an observation is called outlier. So they are beyond the population, or the beyond the higher limit and lower limit of the data that we consider, that we call it as the outliers. Then multicollinearity, when the independent variables are highly correlated to each other, then the variables are said to be multicollinear. Many types of regression techniques assume multicollinearity should not be present in the data set. Otherwise, it's very difficult to differentiate between the data set, right? And heteroscedasticity. Heteroscedasticity, when the variation between the target variable and the independent variable is not constant, it is called as the heteroscedasticity. For example, as one's income increases, the variability of food consumption will increase. But here, a poorer person will spend a rather constant amount by always eating inexpensive food. But whereas the wealthier person may not always take the expensive food. He sometimes may take inexpensive food also. So we cannot say that the income is directly proportional to the food consumption. This is one of the example of heteroscedasticity. Right. So in the next video, we will discuss about other regression techniques also. Thank you.